Hello and welcome to Algebra 1. I've had so much time on my hands, as you can see. I am making introductions to music. Oh my goodness, being at home all day, all the time is such a struggle, but I always look forward to class time where I can make a video for you, then you can come to office hours and we can do some math from home. So we're going to start with some updates and announcements. Then we'll do our bell work review, notes. Then you'll end out with your skill check and IP. So, celebrations, announcements, and struggles. It's been funny reading you all's. Someone said that their struggle was bread. Someone else said that they really miss being at school, and I totally understand that. Someone else said that they're stuck at home all day. I definitely agree with that. Someone said that they had no struggles, which is nice. So keep adding those, keep posting those struggles, announcements, celebrations. Those are really cool to see. All right. Only a couple of announcements today, and that is a reminder that office hours is from 10 to 11 a.m. every day. And you can find the link on Haiku. Okay, I update that link every day, so you can click on it and come and talk about math or just say what's up because I'm bored, okay? Another announcement is please continue to email questions and missing work. 3 of you have done that so far. Shout out to Selena, Ruchapa, and there was one other. Oh my goodness. Selena, Ruchapa, and oh man, I have to go to my emails and look. Oh, and LJ. Awesome. Yeah, so shout out to y'all for emailing me your questions and your dividing polynomials assignment. Awesome job. If anyone else would like to turn in missing work, please do so. And I will definitely grade it and get it into the grade book by the end of the week. All right, let's pause the video right now if you have not completed your bell work and go complete that now. And when you're done, you can come back and start the video again. Remember, it's 4 points. If you've already done the bell work, then you don't have to pause it and we're gonna move forward together. So the bell work was 2x squared minus 7x minus 15, and you were to factor that. And then the second problem said to factor x squared plus 13x plus 42. So for that first bell work problem, what you need to do is you need to determine whether or not there's a greatest common factor. So is there a number that you can divide 2, -7, and -15 by? Okay, the answer to that would be no. So we would write in no here on our paper or on the screen here. Then we need to identify A, B, and C. So A is 2, B is -7, and C is -15. Now we need to find a number that multiplies to A times C, which gives us -30, and adds to B, which is -7. So those two values are going to be -10 and 3. -10 times 3 is -30, and -10 plus 3 is -7. Once we find our magic numbers, we can rewrite our trinomial. So we'll have 2x squared minus 10x plus 3x minus 15. Then we'll group them. Usually I rewrite the entire trinomial before I group them, but I'm running out of space, so I'm just going to group these original 2 and these last 4 right in the same step. Now, what can I take out of 2x squared and 10x? Well, they both have a 2 and they both have x, so I can take out a 2x And in my parentheses, I will write what's left. Okay, and let's go ahead and show my work here. So I'm dividing 2x squared by 2x and 10x by 2x. Okay, and what can I divide 3x and negative 15 by? I can divide 3x by 3 and negative 15 by 3 as well. So I'm going to write 3 on my outside, and then parentheses will be filled with what's left. So when I take 2x squared divided by 2x, I'm going to have 1x left over. And then 10x divided by 2x will leave me with a 5. And then 3x divided by 3 will leave me with an x. And negative 15 divided by 3 is negative 5. So I can write out my factors. My first one will be x minus 5. And my second one will be 2x plus 3. A lot of you on your bell work were not sure what factors meant, but when I ask you for the factors, I'm asking you to write it in this form here, okay, with the 2 sets of parentheses with the information inside. All right, let's do number 2. X squared plus 13x plus 42. So is there a number that I can divide 1, 13, and 42 by? The answer to that is no, so there is no GCF. A is 1, B is 13, and C is 42. Now I need to figure out what number multiplies to 1 times 42, which is 42, and adds to B, which is 13. In this case, we could choose that 7 times 6 would give us 42, and 7 plus 6 is 13. So we can rewrite our trinomial using 7x and 6x instead of 13x. So we'd have x squared plus 7x plus 6x plus 42. We can go ahead and group these. So the first 2 are grouped together and the second 2 are grouped together. And now I want to see what is the largest value that I can divide x squared and 7x by. And that would be an x. And then what can I divide 6x and 42 by? And I need the largest value. It would be 6 for both. So I take out my x from here, and what will be left is x plus 7. And when I take out my 6 from the second group, what's left is also x plus 7. Okay, so my final factors are going to be x plus 7 and x plus 6. If you would like to go back and update your bell work, you surely can. Remember, bell work is 4 points and it's graded on accuracy. So are they correct or not? Let's move forward. So today we're going to learn about frequency tables. Okay, so sometimes when we examine data, we want to know how likely. Remember, you can take notes on separate piece of paper if you would like. When we do examples, I do recommend that you take notes because I'm going to have some problems that I want you to try and do, and the notes will help. Okay. So once again, sometimes when we examine data, we want to know how likely it is that something will occur. This is called probability. To calculate probability of an event, we need to divide the number of times an event occurs by the total. For example, let's pretend that there are 75 students who watch the e-learning video today. 25 use a tablet, 13 use their phones, and 37 use a computer. Let's calculate the probability that a student is watching the phone on a video. Wow, y'all know I twist my words and it doesn't stop at home either. So calculate the probability that a student is watching the video on a phone. So the first thing we need to do is figure out how many people are on their phones. Okay. Well, based on the data, we have 13 who are using their phones. So that value is going to go on top. Okay. Now we want to figure out how many of people are using their phone out of the total people. So the total number, which is 75 students, will go on the bottom, and this will give us our probability. So when we divide 13 into 75, we're going to get a decimal of 0.17. Now, generally, a probability is calculated as a percentage. So once we create our fraction like we did here, and then we get our answer of 0.17, we need to put this in a percent form. The way that you do this is that you need to move your you move your decimal place 2 spaces to the right. So when we move that decimal space 2 places to the right, our new decimal is behind the 17. So as a percentage, we will write the number now as 17, and then we'll use the percent symbol behind it to show that this is now our percent. So the number of students who are watching the video on a phone would be 17%. So let's calculate the probability that a student is watching the video on a tablet. So remember that total number of students goes in our denominator, and the number of students who are watching on a tablet will go in the numerator. So there are 25 who are using a tablet, and then the total is 75. So our fraction is going to be 25 divided by 75, and that's going to give us a decimal of 0.33. Now, we don't want our answer as a decimal, we want our answer as a percentage, so we would move the decimal place over to the right twice. And our new number is 33 with a percent behind it. Okay, let's try the last one. Calculate the probability that a student is watching the video on a computer. So we want that total amount of students, 75. And then we want the number of students who are using a computer. Remember, the total number always goes on the bottom. The number of students using a computer will go on the top, and we will get our fraction. When you simplify this, you get 0.49. Move your decimal place to the right, and you will get your new number of 49 with a percent attached. Okay? So this is how we determine the number of times that each event occurs. We figured out how many times a student is watching the video on their phone, which is 17%. We figured out the number of students who watched this video on a tablet, and that was 33%. And then we found out the number of students who watched the video on a computer, and that was 49%. Okay, let's move forward. Now, this problem I want you to try on your own. Okay, so if you need to go back to the previous slide and go through those examples and pausing after each one, you can. And when you feel comfortable, come back to this problem and check your work. So it says, if 15 friends go out to Starbucks and 7 order coffee and 8 order tea, what is the probability that one of them ordered coffee? So remember how I said in the beginning that the total always goes on the bottom? Well, in this case, they did not give us a total. In fact, they did. What is Miss Lockhart talking about? They absolutely did. So the total is 15 friends. Okay, so that total value goes in the denominator. Okay. Now I need to figure out who are they talking about specifically? What are they asking me about specifically? Well, they're asking me about the probability that someone ordered coffee. Okay, so that's all that we're going to be worried about is the number of coffee orders, and that's going to go on the top in our numerator. This 8 orders T was really just extra information that we do not need to use. The only time we would have used that 8 is if they did not give us a total, which I thought in the beginning, and we would add 7 plus 8 and we would get that total value. Otherwise, that 8 is not necessary for this problem's question. So when we divide 7 divided by 15, we get 0.47. Move the decimal to the right 2 places, and our new value would be 47 with a percent sign on the back. So 47% of friends order coffee when they go to Starbucks. Next, let's talk about bivariate data. Sometimes when we collect data, we need information about how 2 traits are related. So about how 2 portions of the data are related. This is called bivariate data. For example, suppose we want to conduct a survey on how footwear impacts transportation to school. Specifically, I would like to know if students who walk to school are more likely to wear tennis shoes. First, we would need to collect information in 2 frequency tables. One for students who wear tennis shoes and one for students who wear some other footwear. So, let's say that we are taking a survey of, it doesn't matter, A1, A3, B2, or B4 class. We can pick. And we decide that 4 of us walk with tennis shoes, that 6 of us catch the bus with tennis shoes. Notice the tennis shoes up here. That's why I'm saying that. And then we decide that 7 of us ride the car with tennis shoes on. And then we decide that 2 of us have some other way of getting to school, but they still wear tennis shoes. Okay. Then we decide that the other number of class, let's say this is A3. So say my A3 class, we decide that 9 of us don't wear tennis shoes when we walk to school, so they wear like sandals or something. And then 4 of them ride the bus and they wear Jordans. And 5 of them ride the car and they wear stilettos. And then we have 0 people who wear other shoes and other modes of transportation. Okay, so we now have 2 sets of data. This first set of data is talking about the number of students who wear tennis shoes, whether or not they walk to school, ride the bus to school, or in a car to school. Our second set of data is talking about the number of students who do not wear tennis shoes to school, and they walk, ride the bus, ride in a car, or something other. So we can represent both sets of data in what we call a 2-way table. Okay? So I want to compile these into a 2-way table so that I can see how they both compare. So everything from this column will be written down under here. So 4, 6, 7, and 2. And then everything from this column will be written in this table. So 9, 4, 5, and 0. Do you notice that these boxes here and here are white, and these boxes are gray. Those are called, the ones that are gray, those are called shaded regions, okay? And whenever we have shaded regions in a two-way table, it's called joint frequencies. So all I want you to get from this slide is that we can use two sets of data and put it into a two-way table, and the shaded region is called joint frequencies, okay? So let's figure out how to use a two-way table. To use the two-way table efficiently, we need the totals. We can find the total number of students altogether by looking at the intersection of the total row and total columns. The total number of students in this class is 37. Now, I don't even think there's a class at Riverside that is that big. But maybe there is a class. If you could think of a class at Riverside that has 37 people or more, send me an email, because I definitely can't think of one. But in this example, we are going to talk about a class of 37 students. So we're going to use the same data from the previous slide. So I'm just going to fill that in here for us. Okay. And remember, last time our shaded regions were in the center here. We're on these blocks and these blocks. Okay. This time, let's see if I can delete this stuff. Yeah. This time, our shaded region are these boxes here. Okay. So those shaded regions are called marginal frequencies. So the marginal frequencies are going to be the totals of our columns and our rows. So for our first box here, to get the total, I'm going to add 9 plus 4 to get 13. To get my next total, I'm going to add 6 plus 4 to get 10. To get my next total, I'm going to do 7 plus 5, which is 12. And for my third total, I'm going to do 2 plus 0, which equals 2. Now I need the totals for the columns. So for my column totals, I have to add up all the contents in the tennis shoe column, and then I need to add them all up in the other shoes column. So when I add 4 plus 6 plus 7 plus 2, I get 19. And when I add 9 plus 4 plus 5 plus 0, I get 18. Okay. And what do you think this box is going to be for? In this box, I need to add up 13 plus 10 plus 12 plus 2. And when I do that, I get 37. But before I write that in my empty circle, I need to make sure that 19 plus 18 is also equal to 37. And in fact, it is. So in my open bubble, I'm going to write the total, and it's going to be 37. So we can now use the entire table that we filled out with numbers. We can use those, which is our joint frequencies, and our marginal frequency, to calculate probabilities. So I have our table listed up above for us to, refer to. So we're going to refer to this table here. So it says, what is the probability that a student in class wore tennis shoes? So what we need to do is figure out the total number of students who wore tennis shoes, and that would be 19, divided by the total number of students, which is 37. Here you would get 0.51. Move the decimal place 2 places to the right and put a percent sign behind it for 51%. Number 2. Part B, what is the probability that a student in class walked to school? So we're always going to have our total in the denominator. So our total, we know for sure, is going to be 37. Now, what is the probability that a student walked to class? Well, we need the total for walking students, which is 13. And we would put 13 in our numerator, and we'd get 0.35. Move our decimal place to the right 2 spaces, and we'll end up with 35%. Next, it says, what is the probability that a student in class walks to school and wears tennis shoes? So in order to do this one, we have to do a little bit of critical thinking. Let's look at the first stipulation, which says, what is the probability that a student in class walks to school? Okay, so we need to go to that column first. Let me delete what we don't need quite yet. Okay, so the probability that a student walks to school and wears tennis shoes. So we have to find the row with walks to school and the column that has tennis shoes and match that number together. So that number would be 4. Okay, and then out of our total, which is 37. This will give us 0.11. If we move the decimal place to the right 2 spaces, we'll get 11, and then we'll add the percent on the end. D, what is the probability that a student in class walks to school and wears shoes other than tennis shoes? Okay, so walks to school and other shoes. So let's delete some what we already highlighted before, and we need to underline walks to school and wears other shoes. That number would lead us to 9. So we'll have 9 over 37, and that will give us 0.24. Move the decimal 2 spaces to the right and add a percent sign on the back of it. Okay. Now, using the same table, let's answer the remaining questions about the data. So what is the probability that a student walks to school given that they wore tennis shoes? Okay. So walks to school given that they wore tennis shoes. This given that is very important. Okay. Whenever we see that, our total is going to be whatever follows. Okay, so our total is no longer 37 because we have this term given that. Our new denominator is going to be the value for the total number of tennis shoes. Okay, so that is 19. In our numerator, we're going to put the number of students who wear tennis shoes and walk to school, which is going to be 4. Okay. The biggest difference to this is that our denominator is no longer the total, and that's only because we have this phrase given that. When we see given that, our denominator is going to be whatever is listed to the right of the phrase given that. In this case, it said tennis shoes, so we wanted the total number of students who wore tennis shoes, which is 19. So this would be equal to 0.21. Move the decimal to the right 2 spaces, and you'll get 21. And add that percent sign behind. Let's try again. What is the probability that a student walks to school given that they wore tennis shoes? Now I'm looking at this and I stopped saying anything because this is the same exact question. So 4 divided by 19 equals 0.21, which is 21%. I'm pretty sure that was not supposed to be the same question, but since it is, we're just going to roll with it and we'll be okay. So based on our results from A through F, does walking to school make a student more likely to wear tennis shoes? And we'd say no. Students are only 21% likely to walk if they wear tennis shoes. If we would have calculated this problem earlier and it were different and it said let's do this one differently. Let's pretend that this one says other shoes, other tennis shoes. Okay, so we have that given that phrase, so our total would be the other tennis shoes value, which is, let's delete this here. So our new total would be the other shoes total, which is 18. And walks to school and wears other shoes is 9. So then that will become 0.5, which is 50%. So to answer G, no, students are only 21% likely to wear tennis shoes they're only 21% likely to walk to school if they wear tennis shoes, but they're 50% likely to walk to school if they wear other shoes. So technically, kids would rather walk to school wearing other shoes than tennis shoes. What do you think about that? All right, here is some great practice for you, and there's one more practice problem after you finish this one, and then you can move on to your skill check and your IP, okay? So it says, Debbie counts the videos and DVDs she has and places them into categories, okay? So she has film, comedy, and sports, and the different types are videos and DVDs. So what we need to do is we need to go through and fill in our frequency table with the totals. Okay, so what I want you to do is I want you to try this on your own. Okay, there are going to be questions that pop up to the right of the screen, and you're going to answer them along the way. Okay, so our totals are 76, 24, 59, 17, 24, and 100. Okay. The part B, one of the items is chosen. Calculate the probability of choosing a DVD about sports. So a DVD about sports would be 3 over the total, which is 100. And that will give us 0.03, which is 30%. Okay, a comedy on video. So that would give us 5 divided by 100. And that would give us 0.05, which is, that should say 3%, not 30%. And this is 5%. Miss Lockhart made a mistake. I'm so sorry, y'all. Doing this on the computer is so confusing. Okay. Scratch that. If you were confused about part C, that's because I chose the wrong thing. A comedy on video would be this number here, which is 12. So 12 divided by 100 would give us 0.12, which is 12%. Okay. So we have 3% for the first one and 12% for part B. Okay. So what is the probability of it being a sport given that it is on DVD? So our new denominator is no longer the total of everything, which was 100, but now it will be the total of DVDs, which is 24. So 24 goes on the bottom, and then sport and DVD was 3, so it'll be 3 divided by 24. That gives us 0.13, which is 13%. Okay. And then it being a DVD, given that it is a comedy, well, our new denominator is going to be the total number of comedies. So that is 17. I'm going to get rid of some of these other circles here. So 17. And then a DVD and a comedy would give us 5. So 5 divided by 17 is 0.29, and that is equal to 29%. Okay. Remember, the given that statement tells us that our new denominator is whatever is to the right of it. Okay. All right. Here is another check for understanding. Okay. We have to fill in the table first. That's what part A tells us to do. Whoops, didn't mean to switch that back. So we'll get 7 here, 5, 17, and 30. Next, it says, one of the people is chosen. Calculate the probability of choosing someone with blue eyes. Okay, no given that statement. So my bottom number, my denominator is going to be 30. Then I need to go to the number of students with blue eyes, and that would be 13. So 13 divided by 30 is 0.43, which is 43%. Now, someone with fair hair and blue eyes still doesn't say given that, so our total number is still 30. Our top number, though, is going to be the person with fair hair and blue eyes. So the fair hair column, blue eye row, that number is 8. So 8 divided by 30, that gives us 0.27, which is 27%. All right, part D. Someone with blue eyes, given that they have dark hair. Here's that given that statement. So our denominator should be different than 30. This time, our denominator is going to represent the people with dark hair. So I need to go find all of the total number of people with dark hair. So let me erase my circles here because they're getting out of hand. So many of them. And the total number of dark-haired people is 15. So that's my new denominator for part D. So 15. And then dark hair and blue eyes is 5. Dark hair column, blue eyes row matches to 5. That gives us 0.33, which is 33%. Now, last one is someone not having blue eyes. Okay. So that goes back to our total of 30 in the bottom because I do not see that given that statement. Now my numerator is all the people who do not have blue eyes. Okay, so the total number of people with blue eyes is 13. The ones without blue eyes would be 17. So that goes on top. 17 divided by 30 is 0.57. If we make that a decimal, if we make that a percent, we move the decimal 2 spaces to the right, and we write a percent sign on the back. Okay? Alrighty. You have made it to the end of our lesson on two-way frequency tables. Congratulations. Everyone gets a smiley face. So, at this time, I want you to go complete your skill check, okay? Your skill check is going to be a link on the haiku page. If you need help with your skill check, you can always go back through this video, you can email me, or you can come to my office hours link. If you want to do office hours after 10 a.m. or after 11 a.m., just email me and I'll get right back on the link and I can help you that way, okay? I'm going to give you some hints though. So A, B, C, and D is going to use the denominator of 26, okay? You'll just have to figure out what goes in the numerator. E and F, you have those given that statements. So your denominator for E should be the total number of females. And your denominator for F should be the number of people who voted for bowling. Okay, so those are your hints. Go ahead and stop the video and go start your skill check. Have a great day. Toodles!